All right, the answers to your homework problems. Number 11, you should get 0, 0, and 2, negative 4 for critical numbers. Number 12, you should get 0, 0, the square root of 2 and negative 4, the negative square root of 2 and negative 4. For 13, you get t equals 4, but since it states t has to be less than 3, that one doesn't count. And so you get t is 2 and 2/3, and g is 3.079. For 14, you get 1, 2, and negative 1, negative 2. For 15, you get x equals pi over 3, and 5 pi over 3. So 3 different options. Plug those in, and it'll give you the y value. Number 17, there are no critical numbers. So you test the endpoints, and negative 1, 8 is your max, and 2, 2 is your minimum. For number 18, you get a no critical number, and a minimum at 0 and 5/3, and a max at 5, 5. 19, your critical number is 3 over 2, or 1 1/2, and 2 1/4, and that ends up being a maximum, and your endpoints are your minimum at 0, 0, and 3, 0. On 20, your critical number is negative 1, negative 5, which is an endpoint, and it's a minimum, and your other endpoint, 1, negative 1, is a max. 21, your critical numbers are 0, 0, and 1 and negative 1/2, which are not a maximum or min. Your minimum is at negative 1, negative 2 1/2, which is an endpoint, and 2, 2, which is an endpoint. For 22, your critical numbers are negative 2, 16, and 2, negative 16. Your endpoints are 0, 0, and 4, 16. Your max was the negative 2, 16, and an endpoint of 4, 16, and your minimum is 2, negative 16. 23, your critical number is 0, 0, and 1, 1. Your max is negative 1, 5, and that's an endpoint, and your minimum is the 0, 0. 24, your critical number is 0, 0. Your endpoints are your min and max at negative 1, and 1, 1. 25, your critical number is 0, 0. Your maximums are negative 1 1/4 and 1 1/4. The 0, 0 was a minimum for the critical number. 27, you get a critical number at 2, but that is not your max or min. You get 0 and negative 1/2 as a max, and 1 and negative 1 as a minimum. The 2 is a critical number because it makes it undefined. On 28, your critical number is t is 2, and that's because it makes it undefined. And your max is at 3, 3, and your min is at 5, and then 1 2/3. So, if you have any questions over that, come and bring it next time. And for this next section, it is over increasing and decreasing functions and the first derivative test. Increasing functions mean that our graph is increasing at that time, and decreasing means that our graph is going down. You memorized when you're little that linear equations have a positive slope rise to the right and negative slope fall to the right. So the first derivative test will help us to do that. Here are the rules for the first derivative test. It states that if your first derivative is less than 0, so if your first derivative is a negative number, that means your slope is negative, your graph is decreasing, so your graph is falling. If your first derivative is greater than 0, so a positive number, that means your graph is increasing because your slope is positive. If your first derivative is equal to 0, that means your graph is constant there. We've dealt with our first derivative equal to 0 by finding our critical numbers, which are where we have a horizontal tangent. So, if the slope is negative, your graph is decreasing. If the slope is positive, the graph is increasing. If the slope is 0, your graph is constant. So, for our first example, we're going to find the critical numbers. We're going to state where our graph is increasing and where it's decreasing. And we're going to state if it's a relative minimum or a relative maximum. So on your own, pause the video, find the critical numbers because you know how to do that. So to find the critical number, you find the first derivative, and you get 2x plus 5. So critical numbers are when our slope is 0, so set it equal to 0, and you get x equals negative 5 halves, or negative 2 and a half. And I just solved for x there to get that value. To get your y value, you plug it back into the original equation, and you get y equals negative 2 and a quarter. Or not negative 2, that's a negative 6 and a quarter. So our critical number is negative 2 and a half and negative 6 and a quarter. So to figure out if our graph is increasing or decreasing, we're going to do a chart. And in that chart, we're going to put our critical number of negative 2 and a half as our x value. We know that our slope, or our first derivative, is equal to 0 at that point. We want to know what happens before negative 2 and a half and after negative 2 and a half. So a number that comes before negative 2 and a half is negative 3. And so what I'm going to do is I'm going to plug negative 3 into my derivative. When you do, you get negative 1. That tells me that the slope is negative there. If my slope is negative, my graph is decreasing. So we're going to put in a value on the other side of negative 2 and a half, which is negative 2. If you plug that in to the derivative, you get positive 1. So since my slope is positive, that tells me my graph is increasing. So we have to write the interval. So we have to write from where to where is our graph decreasing. So we're going to say from negative infinity to our critical number of negative 2 and a half. And it stops there. Then we're going to say it increases from negative 2 and a half to infinity. And those are our intervals of increasing, decreasing. So what that means is our graph decreases at first, and then it increases once it hits that critical number right here. So if it's decreasing and then increasing, is that going to be a minimum or a maximum? Well, it's a valley, so it is a minimum. We're going to say relative. And you're done. So see if you can do this example on your own. Pause and go as needed. So your critical number, you find by doing your derivative of negative 12x plus 3. Set it equal to 0. Solve for x. So x is 1/4. Plug into your equation here, and you get a y value of 1 3/8. So our critical number is at 1/4 and 1 3/8. So we get a test on the left and on the right of x equals 1/4. So I'm going to go 0 and I'm going to go 1. I plug those in not to my original, because that gives me a y value, not a slope. I plug it into my derivative so I get that slope. So I plug in 0 and you get 3. You plug in 1/4 and you get 0. Duh, that was a critical number. You plug in 1 and you get negative 9. So since our slope here was 3, that means we are increasing from negative infinity to our critical number of 1/4. Those are both x values, not an x and a y. Then we are decreasing, because it's a negative 9, from 1/4 to infinity. So this time our graph increases, then decreases. So when it gets to that x value of 1/4, it decreased. So is that a hill or a valley? It's a hill. So that is a maximum. Okay, go you, and not just a maximum, but a relative maximum. So you got your intervals, you got your critical number, and you told me if it's a max or a min. So let's try this one. This one's not a little harder because it's x cubed. So pause and go to the end. X derivative is x squared minus x minus 12. So some of you are like, ooh, let's move it around and solve for x and square root. No, no, no. It's quadratic. So you are going to do the quadratic formula or factor. I love factoring, so I'm going to factor. Factor tic-tac-toe, or quadratic formula, negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So this one gives us x equals 4, and you would add 4. This one gives us x equals negative 3. So you have two critical numbers this time. So when x is 4, y is a crazy number like negative 34 2/3. And when x is negative 3, y is a crazy number like 22.5. So here's our critical numbers. In a little bit we will state if they are minimums or maximums. So we go to our chart. I made it bigger because you have two critical numbers. Negative 3 comes first, then 4 on the number line. So that's why I put negative 3 there. I put a space between negative 3 and 4 because our graph is either increasing or decreasing between those values. So I'm going to pick negative 4, 0, and 5. You can pick whatever numbers you want as long as they fall into place on the number line. So if I plug negative 4 into the derivative, I get 8. If I plug in 0, or negative 3, excuse me, I get 0. If I plug in 0, negative 12, 4, 0, 5 is 8. So 8 is positive, so that means our slope is increasing. So we're going negative infinity to negative 3. 0 means it's constant. Negative 12 means decreasing. So negative 3 to 4. We can't go negative 3 to infinity because 4 stopped and made it 0 constant again. And then we increase at the end because it was a positive slope of 8. So from 4 to infinity. So you have 3 intervals there. If you have 2 critical numbers, you'll have 3 intervals. If you have 1 critical number, you'll have 2 intervals. So we are increasing at first. So I'm going to increase until I get to x equals negative 3. Then I'm going to decrease till I get to x equals 4. And then I'm going to increase. So when x was negative 3, that was our first critical number, that looks like it is a maximum. And if you notice, your y value here is higher than your y value there. And when you get to x equals 4, it's down in a valley. So that is your relative